actually not the same object. They are different objects.
But we are not created for E.
We are not created. So when we create E, we will actually create a...
But we are creating E here, right?
No, we are not creating E. We are creating an edge. And this is edge,
Okay.
start and end.
Edge from A to E.
From A to E.
Okay.
So this is the start and this is the end.
If
And
we don't
when-
have E, then how we will point to E?
We have. I have not. This is a simplified class. I have not added things in this that in edge class I would have to add. First, check if E exists. If E does not exist, then I will return null. If this is null, then I will say I'm not going to add this edge in my adjacency list. That is, I'm not doing all the error checks and stuff like that in this. This is a simple solution, right? But if somebody asks you a question, I think if you write a class of edge, a class of this, they will actually be impressed. They will be, yes, this is good. This is not bookish language. This is just like pure, simple, this is how you define a data structure kind of thing. Okay, so I was actually proud of it when I wrote this, and I had to teach the class over here, and I promised that I will do that. And in my office I was sitting, so I sat down from in the morning, and I just like said, okay, I have to write this. 2 hours I wrote this whole thing. So like, yes.
So you took to tonic at that time or not?
No. So yeah, but your brain actually works the best in the morning. So if you actually want to work, do something.
Depends on man to man.
Reach
People
early in
to
the
people.
morning.
Huh?
Reach early in the morning.
Reach early in the morning. Yes.
मुझे तो समझ नहीं आती रात में क्या बात है
इस सवेरे काम ही नहीं होता यार, कभी वीडियो होती है, कभी कुछ होता है, काम ही शाम को स्टार्ट होता है।
हम लोग रात के देवता हैं, आप लोग दिन के देवता हैं।
नहीं अभी जो
इसीलिए आपको सुबह
सिखों में
में
जो बोलते हैं ना अमृत वेला, या जो हिंदू में बोलते हैं कि हाँ अमृत वेला
सुबह का समय।
Okay.
क्या होता है?
आशीष
अमृत वेला होती है, सवेरे सवेरे पढ़ाई भी
यार
सही।
सुबह सुबह एक ही काम होता है।
availability of MID
Yes.
is available here because we are writing the class the add edge function
रात
of
में इतना हो जाएगा,
node A.
कोई दिक्कत नहीं है।
Availability of ID means.
मतलब ये जो
नहीं होता है, मैं तो नहीं करता है। काफी देर से आपको
हाँ, available इसलिए क्योंकि वो हमारा ID तो उनको, it is a member function, right? MID is a member function.
So basically,
So,
when we are
MID
doing add edge,
function
A member variable.
right.
when we are doing add edge, in that case we are passing the weight and we are passing and what is MID? MID is
Start.
start.
Because I'm starting from me.
Okay.
So I'll say start and end is the end and the weight is the weight.
And we haven't used MID anywhere.
No, we have a private variable.
Okay.
Yeah, it's a private variable.
Private variable, and that is the part of your node.
It's a part of me. So I already know, like, yes, this is what I have to do. Okay, so let's do the deleting of the edge. So we'll say a edge star edge is equal to m underscore, oh, yeah. So what we have to do is we have to find, if I have to delete an edge from A to E, right? What I have to do is I just have to go through this adjacency list, find that
E's ID.
the ID, find the get end of this edge, and then check if that C end is actually, if that end is actually that one, and then I just remove it from my array list.
So in terms of space, graph is not good, right?
No, you can do a lot of optimization in this. I have not optimized this. There is, you can use, instead of array list or the vector, you can actually use some other data structure which is.
Because in a big graph, every node has a direction, from A to B or from B to A again. So
Yeah,
you
so
are creating separate objects.
this can have that too, right?
No, so they will create separate objects.
Yes, so
In
to
that
optimize.
case, space-wise, it is not a good
Space-wise, it
data
is not a good one. Instead of the array list, we can probably use a better data structure, but that is okay. Okay. So what we'll do is for
Design that and send it to everyone.
What?
The optimized.
पहले basic तो बना ले.
okay.
ऐसे करके आज जाके ग्राफ ग्राफ तो मैं करूंगा
हाँ।
जरूर। एक दो दिन पढ़ा कर जाके आज ग्राफ तो पढ़ूंगा जरूर।
फिर पहले अगर तुम्हें बेसिक पढ़ना चाहिए ग्राफ बाद में पढ़ना चाहिए। किसी से आज तक पूछे नहीं कब?
Okay.
FTs
So what we are doing over here is we are going to the adjacency list. We are getting every edge, and for that edge we are getting the end, and we will check if the end is actually equal to C end or whatever. Then we actually delete this. So for array list C sharp, it will be a edge is equal to m underscore edges dot I don't know what the C sharp equivalent is for array list, get at position. So this will get that, and we will get the get end. If that is there, then we will actually delete it from that particular.
C# we can directly use as an array.
remove that.
Yeah, remove
At
that.
least we can use a
Yeah.
normal array. Just like that.
Yeah, okay. So that is the case for delete edge. There is a function called get id. It returns just the m underscore id. Then there is a function called get neighbors.
So add and delete are looking pretty much simple, right?
It's very simple. Everything will be very simple, and everything will come together when I write the graph. Okay. So get neighbors.
Get neighbor, that means you are asking for the vertex.
For all my neighbors.
All the connections.
Yeah. So what?
No,
this
get
is
neighbor is not for vertex, it's for nodes, na?
all the nodes. Yeah.
All the nodes. Yeah.
Yeah. He's saying nodes is
That
vertex.
means connection, vertex.
He's saying nodes, that's what?
A vertex and node. He's saying the same thing.
Vertex and node both are same thing.
Vertex is edge, na?
No,
I-
edge is a separate thing. Edge connection
Vertex-
is the same thing. Vertex and node is the same thing.
I don't know about that, but we can. we can check.
I'm sure.
But okay. So anyways, we'll just take node and edges. So in this case, what I am doing is I'm actually returning a character. So vector of char. So I'm returning an array of characters or array of IDs. So all I have to do is std colon vector of chars neighbors, and then I am going to for integer I is equal to 0, I is less than blah blah blah, like that, m underscore edges dot size and stuff. I will say neighbors dot pushback m underscore edges of I arrow get end.
यार ये पुशबैक होना चाहिए तो पॉप है।
पॉप थोड़ी कर रहे हैं, निकाल थोड़ी रहे हैं
Get वाला काम हो रहा है।
We are just pushing. We declared a neighbor array list, and we are adding all the characters in that, and then returning this. Right? So this is the get neighbors function. Is visited will just return is visited. Set visited will set the visited, and number of edges will actually return
Number of
the m underscore edges dot count or whatever. Yeah, okay. So this was the edges, which was actually pretty simple. Now we'll go through
This was the node.
node, yes, node, and then we'll go through the
Graph.
graph. Okay. So class A graph, which has a public and a private. So a graph has a list of nodes, right? So we will say std colon vector of a node star m underscore nodes. Okay. So it has a list of nodes. We actually don't need to declare a list of edges because nodes contains a list of edges. I don't need to create a list of edges. and then we will have a character m underscore start node. So this will be the start node where we want to start. Okay. Public will be a graph tilde a graph, and then void add node a node star node. Okay. So we'll say I want to add this node to my graph. Right? That will be the function for add node, and a node star get node and character ID. So if I want to get that particular node instance, I will call this function. This function will go through all the nodes which are there in the graph and return me that object. Yes? Character get start node. This will get me the start node. Void set start node. Set start node, we will set this as the start node, and then
This will have a C star.
huh?
Argument pass होना चाहिए set start में.
Oh yeah. Sorry. Character C start. Character C start. Okay. And then reset visited. If we want to do the depth first search, breadth first search, and then there is a void breadth first search, and starting will be character start.
So reset visited is for the node.
Reset visited is for the entire graph. Entire graph will go through all the nodes and will say every node is not visited. And then we will say breadth first. I know there is not optimization and stuff like that, but we are not doing that.
Basically, whenever we will do the searching, traversal, we will set it as a visited.
Yeah.
So at the end, after
So
that,
in-
it has to be reset.
Yeah. So in the start,
We don't have something like end node. Like
Huh?
we have start node. We don't have end node condition for graph.
No,
why the
Just like
graph
here.
is there's no start and end, right?
Yeah, but we are mentioning start node, right?
right. We
We
should have one pointer.
we want to say there's a graph, and then we want to say that I want to start visiting from A. Then I'll take that A as the start node.
No, but to create a graph, you need something to start, right? So at that point, we
Right,
are
right.
a start. But now the graph is created, you
Yes.
can start searching from any
Anyone.
Any node.
Any node.
But still, you should have a one point to get into the graph.
Yes.
Just like a node, head node in the linked list.
Yes, and that is the m underscore start node.
Right.
That is the m underscore start node. Okay. So the constructor a graph colon a graph.
Yes, yeah.
Okay. M underscore start node is equal to null. So we'll set the start node as null right now because there is nothing, and then a graph tilde a graph. What this is doing is it will go through all the nodes and then delete all those nodes. So for int I is equal to 0, I is less than underscore nodes dot
Length.
I think it's
Count,
size,
whatever.
yeah, size I plus plus, and then a node star node is equal to m underscore
nodes
dot
get
back gets the back.
back and I we will be giving
No, a back just gets the back.
on the top item from the list.
Bottommost items,
Okay,
and then we'll
bottom.
pop it out, so we'll always get the bottom list. Delete node m underscore nodes dot pop back. For C#, this would be m underscore nodes dot remove
At
at I. That's all.
Right.
Okay, so that is the what was this? Tilde.
Tilde.
Okay,
This is destructor.
this time. Okay. Now we will do add node. Add node and a node star node. Okay? A node star node, and then what we'll do is we'll just do m_nodes dot push back node. Because node is already created, we just want to add it on the on that list of nodes. Okay, get node is a simple for loop. Get start node will return the m_start node. Set start node will set m_start node to a character C. And I will just write this, the get node. Character ID. Okay. So for integer I is equal to 0, I is less than
And what is the return value? Get node.
a node star. So it returns a node. Okay, so node dot size I plus plus. Okay, a node star node is equal to m_nodes dot add I. So it gets the ith value, and we'll check if node arrow get ID is equal to ID, return